one of the other kinds of equation you need to know is acceleration for forces of motion. So we need to know and use the relationship between acceleration, the change in velocity, and the time taken. But first we need to consider, what is acceleration? Acceleration is the rate of change in velocity. The most important word in that definition is rate of change. And notice that it's velocity, not speed. Speed is a scalar and velocity is a vector, i.e. velocity has direction, but we will look at more at scalars and vectors in due course. If you have a look at the diagram below, you can see this in a visual representation, showing that as you speed up forwards, acceleration increases in a forwards direction, and as the car slows down, it is accelerating but in a backwards direction. So let's have a look at the equation. The equation is A equals V minus U over T. Rearrangements, you need to know about this, but it's more part of the SUVAT equations, which we'll look at in due course. The units for these words, A is acceleration, which can be in meters per second squared, also meters per second squared, or meters per second. Velocity is in meters per second, and time is in seconds. So now that we know how to use the equation, let's put it into a problem. The problem is Max accelerates from 10 to 15 meters per second in 10 seconds. What is his acceleration? So the first thing you should always do is make a list of knowns and unknowns. We know that our initial velocity is 10 kilometers an hour, or meters per second. We know that our final velocity is 15 kilometers an hour. So our time is 10 seconds, and we can substitute that into the equation and get 5 over 10, which is 0.5 meters per second squared. Apologies for the mistake with kilometers per hour. And the marks are allocated towards stating and substituting, and then answering with the correct number of significant figures.